Hello everyone. We are starting today with a new series of GFG problem of the day. This is our first question, and this is an interesting question, by the way. Means how you think about it. If you can see the stats as well, the submissions are fine, but the accuracy is 15.6%. So yeah, we'll see why people try to fail with wrong submissions, and we'll see the entire thought process, and we'll try to reduce this average time as well quickly. Cool. And if you're new to this channel, make sure you hit the subscribe button, make sure you hit the like video, and also we started a new OA series where we explore good OA problems and try to explain you that how can you solve that will help you in your internships and placements. Cool. So let's get started. What does the problem says? The problem says that minimize the heights. Okay. You're given an array denoting the heights of n towers and a positive integer k. For each tower, you must perform exactly one of the following operation exactly once. Exactly once. You have to perform the operation. That's very important. Increase the height of the tower, but decrease the height of tower. Yeah, that makes sense. Decrease the height of tower or increase the height of tower. Fine. Find out the minimum possible difference between the height of the shortest and the tallest tower after you modify each tower. Means you have a modified array, you maybe increase it plus k, then you decrease some with minus k, and sort of, and then finally you have a modify heights of the tower. You want to find the maximum, minimum, but you want to minimize that. Okay. So you want, okay, this is fine, and then you want to minimize this difference. Then it's very, very important. It's compulsory to increase or decrease the height of each k by each tower. For the we have to increase by k, okay, or decrease by k. After each operation, the resultant array should not contain negative integer. That's also a very, very important condition. If it is making is negative, we have to positive, make it positive. Let's say this is 3, our hi, and let's say k is 5, so you cannot decrease it, you have to increase it to 8. That's the thought process. Cool. And let's see an example as well. So it says 1 5 8 10. Then what we are doing essentially is increasing it k, we are decreasing in 5, we're decreasing in 8 and 10 as well. So and this we find the resultant array, the minimum is 3, the maximum is 8, and the answer is 5. Right. How would you think about that? What we do? Okay, what does the first thought come to your mind when you this see this kind of question, right? Means we want minimum, we want maximum, we want to, it could happen that after applying the operation the minimum and maximum could change, right? Initially there is a minimum and a maximum, but after applying the operation it could happen, we are applying in such a way that we are increasing the smaller elements, we're decreasing the larger elements. That's the entire thought process, right? So what if we firstly sort the array? After the array won't be sorted, but initially the array will be sorted. Sort the array initially. Sort the array. Cool. Now what we'll get? This will ensure you that you will get a sorted thing. Fine. Then what you're trying to do is what's the initial difference? What do you start with? And I will be like, okay, what if I just do the maximum minus k and the minimum plus k? That will definitely reduce my difference, right? And I want to do that. So it will become like 10 minus k is like 2. So it becomes 8, and this becomes 3, right? We initially started with a difference of 5. Fine. Now what we want to do is, as we iterate, what we will do is we will increase the previous element. We mean increase the current element sort of, and then the next element we will decrease it because we want to reduce the difference, right? So what you gonna do is we're gonna check that we will gonna do this like this, we're gonna do like this. We'll see what will happen and what we are trying to do, and then we will keep a track of mini, and we'll keep the track of maxi as well. Okay. We'll keep a track of mini variable, and we keep a track of maxi variable as well. Hmm. And then as we go ahead, we'll try to update it. And what will be our difference? Our difference would be minimum of the difference we have encountered, calculated so far, and between the maxi minus mini. Right? This is the entire thought process we have. Now what we are doing is See, why we are doing the plus k on the current ARR of I and minus k on that? Because we want to reduce the difference, right? If we do the reversal thing, that won't reduce the difference, right? It will increase the difference, and then we won't want it. We want to reduce the difference. Fine. And we have sorted it all also. That means the adjacent elements are already closer to each other. If you do this into your original array, that won't help, right? Because some elements would be larger, some elements would be smaller. So you don't know about the semantics about that. Okay. So we have 1, you have 5, you have 8, and you have 10, right? So what are you gonna do? You just increase it. You just increase it, it becomes 3. You decrease it, it becomes 3. And what you gonna do? You update your maximum, you update your minimum. So what your maximum would be updated with? Maximum would be updated with maxi, comma, yeah, that ARR of I plus k, right? Because this is increasing. Because this we already incorporated. This is already larger than this, right? So we already incorporated that. So mini is equals to minimum of mini, which we initially encountered, comma, ARR of I plus 1 minus k. Okay. These are the two things you should think about, right? So we encountered a maxi, we encountered a mini, fine. And we keep on updating these things until the array n minus 1 index. And then we will maintain this difference as well. And then finally we return the difference. So why we thought about that? Again, let's try to walk through about that. What we want to do, our idea is very simple. We want to minimize the difference between the maximum and the minimum. Then what we initially started with, we initially started to make the maximum largest element smaller and increase the smallest element, right? We started with this difference. Fine. But is it the final answer? No. We have to check. Maybe we can get a better answer, right? We can increase some middle element and we can decrease some middle element, and somehow we can get more better answer. So that's why what we are doing it, we are keeping a track of maxi, which is the maximum available element until now, right? So it could happen that, right, k is very large, k is let's say 10, and let's say all elements are 1 2 1 2 range, right? You can see that 1 plus 10 will become the largest element, maxi, right? So that will update our answer. So that's also very, very important. So you should also take care of that. And also similarly, we'll keep the mini. Some edge cases are very, very important here, that we cannot uh, do this operation if this element ARR of I minus k becomes negative. Okay. So we cannot do that. That's one thing we should always keep in mind. Also, when we are doing this uh, initially, right, mini initialization, that's also, it should not become negative. If it is becoming negative, then it means we have to increase it value, right? Okay, that's fine. And also one more thing, if there is only one element, that's also another edge case. So if there is only one element, we cannot take the difference with other elements. We just return that element, right? So I hope you get the intuition why we have sorted it, why we applied that, and how we have thought about the entire question. Let me just walk you through the solution. That what we did initially. Okay. But we did one more thing, that I removed the duplicate elements because that won't contribute to the answer, right? If you have a mini and again it will just calculate it. It's just better you just do a good thing, like try to remove the duplicates. It will ease it out your answer. Okay, you just know that next element is larger than you. That's fine. Then we make it sorted. We make it just copying the element from this side. That's all. If n is equals to 0, there's only one element, so no difference. So you can return the 0. That's fine. Now we have sorted it. It's already, by the way, sorted, so we don't need to sort it. But okay, fine. Now what we initially started with, it's very important. Maxi is ARR of n minus 1 k. What's mini? Mini started with ARR of 0 plus k. Okay, we started with it. And we started the difference with this. ARR of n minus 1 minus ARR of 0. Okay, we started with this difference. Why it happens? Let's suppose that this is the situation I was talking about, right? And the k becomes 10. So actually we are decreasing this also by k, and we are increasing this also by k. So the answer could not be larger than that. That if you increase everything by k, right? That means there is no answer, that the maximum minus the minimum is the final answer. So that's why we initialize the answer with this. And then what we are essentially doing is we are increasing the current element by k, that I was told, and we are decreasing the current next element by k. Okay. And this will change for the next operation. Now you will think, oh, you firstly increased it and then you decrease it. No, no, we are not actually changing the value. We are just simulating that if we change it, then what's our answer? It's like that. See, I am not changing the AR or a phi somewhere else. It's not that I have updated it. No, I am checking if I have changed like that, what would be the impact on my answer? And it's just minimum of current. Okay. Then we have calculated our answer. Make sure that we are maintaining our max current, min current. That max current would be changed by because we're increasing it. So then it might change, right? You can see that it might change. And the minimum is error of I minus and just go on and just maintain the difference and finally the return the difference, right? Also, if you think about here, that what if it becomes negative, maxi becomes negative here, no problem, right? When we go about here, it will update it, so no worry about that thing, because we are not taking the answer from there initially. The initial answer is taken independent of this maxi minus mini. We're not doing that. That's why I told I was doing from here, right? Cool. So I think you get the entire gist of the question. This is a good problem to start with. It's a good sorting problem. But yeah, you should understand the complete solution. If you have any doubt, do let me know in the comments and do check it out the way series as well. Stay tuned. We'll come with more elegant solution and all.